Hello, my name is Yasen and welcome back to my video tutorials on the GCSE mathematics specification. Today we're going to have a look at factorising quadratics. Mainly our questions are going to have a look at coefficients that are greater than x squared, for example. So, the concepts are the same compared to just factorising expressions with x squared alone, so x squared minus x minus 12 as you can see. But yeah, other than that, let's try and jump into it. Alright then, so let's try to have a look at question 1 here. So we're told to factorise 2x squared plus 5x plus 2. So the general format for any quadratic expression or equation, or in this case an expression here, is always given in the format of ax squared plus bx plus c, okay, where a, b and c are integers. Alright, so a, b and c are integers, so they're just normal numbers. So as you can see here, so I think we could sort of try and color code this. So this is black, this is red, and this is green. So let's do that right over here again. Black, red, and green. Right? So you can really compare the general expression to what's given in the question, for example. And from there you can really point out what A, B, and C are. So for question 1, A is going to be 2, B is going to equal to 5, and C also equals to 2 as well. So before starting to factorise any quadratic expression, we always need to figure out what A, B and C are. And of course, preliminarily speaking, we always need to know the format that's given for any general expression, which is ax squared plus bx plus c. Alright then, I hope that's all cleared things up for this question so far. Now, for us to actually start factorising here, our first step is going to, we're going to multiply a by c and find two pairs of factors of the result of a and c, a multiplied by c, sorry. So we're going to use the result of the multiplication of a by c to find two pairs of factors that also add to get b. Okay, I know that was a bit too much to sort of digest for now, but if I try to sort of put it into numbers, letters, and words here, I guess most of you in the least will at least sort of have some level of understanding of what's going on here. So our first step is to multiply a by c. I'm just going to circle this just so that you guys understand that we have to multiply a by c, fetch two pairs of factors of the resultant value of a and c to add to get b. I know this is too much wording here, but I'm hoping if I actually try and do the real math here, the most of you in the least would actually follow. Right then, so let's try and do this then. So the resultant value of a and c, so the resultant multiplication of a and c, is going to be 2 times 2, which equals to 4. So now that we got the resultant value of a times c, which is 4, I need to find 2 pairs of factors that multiply to get 4, but add to get 5. So we have 1 and 4, and we have 2 and 2. If I multiply 2 by 2, I'm going to get 4, but it's not going to add to get 5. But if I multiply 1 by 4, I do get 4, and it adds to get 5, which is b, which is what we said here in this rule. So we need to again find 2 pairs of factors of the resultant value, which is 4, of a and c, to add to get b. So it's 1 plus 4, which equals to 5, which equals to b. Right? So now that we know the 2 pairs of factors that multiply to get 4 but add to get 5, or b, we have essentially broken down the middle expression, which is 5x. We've broken down the coefficient of x here, and what we're going to do, and the reason why we do this in the first place, is to actually individually split down the expression here so that we could factorize in 2's. So I'll show you what's going to happen here. So we're going to get 2x squared plus x plus 4x plus 2. So you could say 1x here because it's 1 and 4, but 1x obviously is x, right? That it means the same thing because x is the base and the one following that is the coefficient, of course. If any of you guys are wondering, you could have this the other way around as well. So you can have 4x here and you can have x or 1x on the other side. It really makes no difference at all into what's going to happen later. So that's our step 2, which we've just done. So our step 2 was to essentially write down the factors that add to get b but multiply to get a times c in the middle to split down bx and write it down, right? So we're going to see, so I didn't really explain that properly, so apologies for that. So we're going to say split down bx into its pairs of factors of a times c, I'll say in brackets, as done in step 1. Yeah? Okay, so we're nearly there. So the reason why we've done this in the first place, like I said earlier, is just for us to split this down into 2 separate expressions. So it's the same expression altogether, but we're just splitting it down just so that we can individually factorize and get the final answer. So I'm going to split it down right down the middle here. So we've got 2x squared plus 1x, or x, and we've got 4x plus 2. Right? Now, as you guys can remember from the previous topic, well, when we were factorizing in a linear fashion, which is exactly what we're going to do here, we are going to factorize 2x squared plus x and 4x plus 2. So obviously, as we know from the previous topics, to factorize 2x squared plus x, the common factor that goes on the outside is going to be x, brackets 2x plus 1. So I should have mentioned this, I believe I have mentioned this earlier in the video, but some preliminary topics required is obviously knowing how to find pairs of factors as well as linear factorization, right? It shouldn't really be said, but of course quadratic factorization is built on top of linear factorization. So some preliminary knowledge of linear factorization and finding pairs of factors is required for this topic. So we have x brackets 2x plus 1 after we factorize this expression here, plus 4x plus 2. So to factorize this, 2 goes on the outside, brackets x, 2x plus 2, sorry, because 2 times 2x is 4x plus, oh no, I've done something wrong here. It should be 1. Bit of a mistake there. There we go. For some reason it was just not rubbing out. There we go. Made a bit of a silly mistake there earlier, but hopefully everything is corrected. Yeah, 2x plus, oh no. What was used earlier? I think it was a marker. No, it was not. Let's see what's going on here. Why can't I get the normal? Yeah, there we go. Sorry about that, guys. I really don't know why I'm sort of being a little stupid with Microsoft Paint, which anyone knows how to use. Anyways, so we've got x bracket 2x plus 1 plus 2 brackets 2x plus 1. Now, I'm pretty sure most of you have already noticed something a little special here. Probably noticed that these two are identical to one another, and they have to be identical to one another, because if they're not, you've done something wrong. Okay? So I'm supposed to write down step 3 here. Let me just try and scroll down with my mouse instead. For some reason that's not working properly. Okay. So step 3 was for us to factorize individual expressions. Oh no, what am I doing? For some reason, it could scroll down. I mean, this pen's really messing up. So I do apologize. Individual expressions. Factorize individual expressions as shown in red. Alright? Okay, so now that we've got that out of the way, let's go back here. So we got x bracket 2x plus 1 plus 2 brackets 2x plus 1. So these two have to always be the same. Our last step for us to actually factorize, we need to grab this factor and this factor, put this into one bracket, x plus 2, bracket 2x plus 1. And that's our final answer. So I'm just going to write it again here, x plus 2, 2x plus 1. And the reason why we do this to get our final answer, you really need to sort of visualize what's going on in the question itself. You have to bear in mind, as I've split down the two pairs of factors and wrote down this longer expression and then split down this longer expression so that we could factorize in a linear fashion in chunks, you have to bear in mind this is the same expression at the end of the day. So because it's the same expression at the end of the day, you have to realize that 2x plus 1, the two 2x plus 1s here, are identical to one another, and they are factors of the same expression. So let's pretend that these are real numbers, 2x plus 1 and this other 2x plus 1. Obviously, because they are completely identical to one another, let's just say the value of 2x plus 1 was 4, right? You wouldn't write down 4 twice as the factors. There's no point. of doing that. It's moot to write down 2x plus 1 twice, okay? But x and 2 are still factors of 2x plus 1, so this is why you put them into their own individual brackets. I'm hoping that made sense, but if it did not, please hit me down in the comments, or try to email me as well, and then I could sort of get back to you in sort of explaining that a little further. So let's write down our final step here. So our final step was to, what was it again? Identify identical brackets labeled in green, and pick out the outer pairs, I should have said that, outer pairs. Microsoft Paint is really stupid to use. I don't really know. It's really annoying to use. I think I should use something else instead of this. I think it's just the Windows 10 version of Microsoft Paint. It's just really useless at this point. And pick out the outer factors into its own brackets. So the wording here is not as great, so I really do suggest to everyone to just rewind to when I was actually trying to go over the question as demonstrated here. I really just put things into words here just to sort of organize what's really going on in the question itself. But I'm hoping if you try to rewind the video and actually see how I'm actually trying to go over the question, it makes much more sense than the actual wording here. So again, just to reiterate what we're doing, we are multiplying A by C, finding two pairs of factors to get the resultant value of A times C, but add to get B, which is 5, and they have to satisfy both conditions in order for us to split down this expression into a much longer expression as given here, and split down the expression itself into two linear expressions factorized individually, and grab the outer pairs of factors into its own brackets, and grab the other linear expression and use that as the final answer, which is the final answer. So it'll be x plus 2 brackets 2x plus 1. Let's go over another question just so that we could actually clear things out. Where is my mouse? Yeah, sometimes it just doesn't show. It could show on OBS, but it's not showing. Yeah. Alright then. Let's have a look at question 4 here. So we're now dealing with negatives, as you can see. But at the end of the day, we are following the same principle as what we were doing with the previous questions. The principle on factorizing these quadratic expressions is always the same. But obviously things can change when you're dealing with these pesky negative signs. So let's actually go over this. So the first thing for us to do, of course, is to write down what A is, what B is, and what C is. A is 2, B is minus 1, because you have to factor in the negative sign. So it's, of course, as I've said earlier, minus x is the same thing as saying minus 1x. So B is minus 1, and C is also minus 1 as well. So we're going to multiply A by C, so A times C equals to 2 times minus 1, which equals to minus 2. Alright? And we're going to find two pairs of factors that multiply to get minus 2, but add to get minus 1. So, you know how I've been saying earlier, we have to find those two pairs of factors to multiply to get what a times c is, but also add to get minus 1. You have to factor in the negatives as well. So maybe at the end of all this, you'll see that it's technically subtracting because a plus and a minus makes a minus. But it all makes sense when I actually figure out what the pairs of factors are. So we have minus 2 here. I'm just going to split it down. So we have 1 and 2, and we have 2 and 1, which is the same thing. So 1 and 2 can fit to minus 1 somehow, but because we're dealing with a negative here, the negative either has to go here or here. I mean, I would say it would have to go on the minus 2. Because if I place this negative on the positive one, so if this was minus 1 and 2, that would make plus 1. So I'll write down b is minus 1 here. So if this was minus 1 and positive 2, we would not get minus 1, which is b, because plus 1 minus 2, or plus 1 plus minus 2, so I'll write it down here, so plus 1 plus minus 2 equals to minus 1. Sorry, I was supposed to say this whole thing the other way around. This whole thing was a bit of a mistake. I was meant to say minus 1 and plus 2. So let me just get that out of the way. I think my brain is for some reason not working as it should. So if I was saying minus 1 plus 2, which equals to positive 1, which is not the same thing as negative 1, obviously. But if I have the minus on the minus 2, so minus 2 plus 1 equals to minus 1, which is correct. Or you could say 1 plus minus 2, which equals to minus 1, which is also correct as well. So again, like I've gone over in the previous question, you count the pairs of factors either way around, but you need to figure out where the negative is going, because that does make a massive difference. Because as you can see here, if we have the negative on the 1, then we're going to get positive 1, no matter what. So even if I have 2 plus minus 1, that's going to give us plus 1, which again is not the same as minus 1. Okay? So let's try and, so now that we've got the two pairs of factors, let's try and write the longer expression. So 2x squared minus 2x plus x minus 1. So that's the longer expression given here. And we are going to split this down as what we've done in the previous question. So again, the x could be here and the minus 2 could be on the other expression as well. So, well, it's all the same expression, but just on the splitted down version. So you can have it the other way around. That's really my point here. So obviously the common factor that goes on the outside is 2x, brackets x minus 1, plus 1, brackets x minus 1. Okay? And I'm just going to put this down in green, just to signify the fact that these two brackets have to be identical to one another. If they're not, you're obviously doing something majorly wrong here. Sorry, let me just fix that. There we go. So, like I said, these two brackets always have to be identical to one another. We're going to put these two outer factors into one bracket, so 2x plus 1, and that always happens whenever you're factorizing any quadratic expression, and the other one's going to be x minus 1. And that's our final answer, so 2x plus 1, x minus 1. Please hit me down on the comments if you have any questions at all, or even try to email me if anyone can find my email somehow. Should be somewhere on the YouTube homepage. If it's not, I believe you can find it from my YouTube handle somehow. But I will try my best to obviously leave my social media details just so that anyone can reach me if they have any questions at all. And I'll be more than happy, free of charge, of course. That shouldn't really be said, but free of charge, of course, to help anyone that's struggling with any of these questions. And I'll hopefully get back to you by email, or even send you a free of charge video solution to the question that they're stuck with in regard to the topic that we're going over today. Please like and subscribe if you've enjoyed this video and actually learnt at least something from it, or benefited from it. And yeah, hope to see you in the next video, guys. Take care.